Are we on? All right, great. Good morning, everyone. It is so nice to be in San Diego, especially if you live in Seattle, like much of the EKS team does. Little warm weather. We should have had the event outside, I think. That might have been fun. Welcome to Container Day. Our theme for today is going to be a very important topic, GitOps. What is GitOps, you might ask, and why does it matter? That's what we're going to talk about. And so I'm going to tee this up, and then we have the other speakers who are coming on after me who are going to go into even more detail. But I think it's really important for us to understand the why as much as the what, and to understand where we're headed with all of this. So DevOps, GitOps, Kubernetes, containers, all of these have common motivators behind them, this big shift that's been happening in our industry in this direction, largely around business reasons. Leadership at a company wants to go faster with better quality. And what has been evolving is really massive gaps in what companies who adopt certain kinds of approaches versus companies who don't. So there's this velocity gap that's measurable and observable. And it's not just the gap between the top performers and the bottom performers. It's the big gap between the top performers and the average performers that's really showing up here. And of course, combined with all of that is a desire in all of these groups, these companies that are trying to attack this business problem to, at the same time, not have so much sprawl. Can we constrain things a bit, be a bit more efficient, have a smaller, be better at a smaller set of things, and to use some common approaches between teams. And then it's a lot more fun to work on a team that's operating in this kind of high velocity way. People enjoy it a lot more and becomes important to people's careers and to their happiness on the job. So in this path to try to solve these kinds of business problems, there have been a lot of evolution in process over the past 30, 40 years. The more traditional approach has been widely recognized as kind of a spiral to slowness. This is mostly a human factors issue. If you try to do bigger things, they get more complicated, and when they get more complicated, it takes even more time to try to get them right. And when you have large releases, when you do large things, then the risk goes up for every big thing you do. And then when there's a failure, the tendency is to try to layer in even more and more kinds of processes. And so what happens is things go slower and slower and slower. On the other hand, you can go faster and get faster at going faster if you take an approach that is based on taking small chunks and using robots. Automation. I use kind of automation and robots interchangeably here. I think robots is a more fun way to think about it. Also, I think probably a lot of you know that a lot of the inherent design principles in systems like in Kubernetes come from the robotics world. So there have been an evolution in these kinds of processes. And there's also been a recognition that if you want to try to move from the spiral of slowness to a velocity flywheel, there are some strategies, good strategies for how to get there. One of the most interesting things here is that the key to success here is a focus on the operations side of the house. And I'll say instead of the dev side of the house. And what I mean by that is that we've spent many decades at this point optimizing developer flows and developer velocity with a little bit less attention played on the operations side. And especially in the DevOps world, when you start thinking about DevOps, it's how do you bring those worlds together? How do you use the same techniques and approaches in both? But in a lot of cases, those approaches have been used in the development side, but we haven't actually been as effective at getting them deployed into the operations side of the world. So that's why I hate saying the word CI/CD, because these are different things with kind of different audiences. So I always try to break them apart and talk about CI and CD. Most of what I'm going to talk about today is really oriented towards the development side. Also, this idea of not trying to do too much is important organizationally. This is all human factors, really. An incremental approach is not just about how you use effective automation, but how you work with groups of people effectively as well. And I would say this, really important, microservices is not a panacea, especially if the organization doesn't have the tooling and practices to manage more smaller things effectively as they do their monoliths today. So I would recommend strongly, think about operations hygiene as a really critical prelude to doing any kinds of microservice re-architecture. That's, again, like make sure the operations world is working really, really well before changing the development world too much. And I would say the hygiene things here are continuous deployment, CD, observability, and orchestration. Okay, so more evolution here that's been going on. We already talked about this a little bit. We're moving from people to robots. That is not just true in the IT world, that's true across, I would say, all of our industries. We've been moving from package managers to immutable images. So we're moving manual processes to automation. We're moving from package managers that may change things in a running system to an immutable image approach. We've moved from configuration databases, CMDB, to configuration as code. We've moved from siloed teams to integrated teams and tools. I would say that line is really mostly what DevOps is about. How do we have integrated teams and tools as opposed to having very different kinds of teams and tools doing different things in the life cycle. And again, focus on dev productivity is good, but understanding where the real bottlenecks are in your system is really important. And I would say most teams have much more difficulty on the deployment side, so figuring out what the holistic velocity is really important. So package managers, maybe you've been doing package management, and that's actually good. That's a good practice. There's still a lot of bash out there and scripting. A lot of folks are still using, you say CMDB, and that sounds fancy, but it turns out it's actually spreadsheets. Well, there was a chuckle from the audience. That one probably hit close to home. And then also, like, how do you not be throwing things over the wall from dev to QA to security check to operations? How do you integrate all of these things into a single world? Really, that is the DevOps philosophy. And then a focus on CI is good. Lots of teams do CI really well. I would say for most teams, that's a pretty well-solved problem, but fully automated deployments. CD is kind of shorthand for fully automated deployments. How often you do it is a question of how small a bite you can take. It's really more important that it be fully automated. You can start there, and then you can reduce the cycles as you go, but it's really hard. Like, there's a reason why this is the next problem to solve. We've made lots of progress on the development side. There's new ground to be gained here. And this is some of the reasons why it's hard. Like, you have big, complicated systems. There's a lot of interdependencies. There's a lot of steps that have to be taken. You have to worry about packaging and dependency tracking, and what do you do about versions when you have multiple versions, and maybe you might have to worry about multiple versions in production at the same time. How do you manage rollbacks if you have a whole set of complicated steps? How do you undo that set of complicated steps without breaking everything? So this is a really hard problem. So what's been going on? What's been the evolution of how to tackle this really hard problem? And these are the approaches that have been evolving that have been shown to be effective. So one of the big steps is to move from an imperative world to a declarative world. Don't tell the robots, do A, do B, do C. If C doesn't work, do D, do E. Describe to the robots what you want. Let them worry about how to create the system that you've asked for. Automated mutation. So, like, one of the best practices, if you went back 10 years, was write lots of code. Don't touch those production systems. That's a good principle. Having systems reach out into production and install packages and change things is better than having humans do it, but there is a better way. And the better way is to approach things with immutability. So rather than having production systems where code is being changed, packages are being updated, take an approach where You build the thing you want, you test it, you move it to staging, you move it into production, and when it needs to be fixed, you don't change it, you throw it away, you build the next thing, and you replace it. Also, single state. I'm going to deploy X. X is in production. Well, this turns out to be really hard to do on large distributed systems. And the other thing that's interesting here is that most of us are building large distributed systems. Cloud computing, Kubernetes, all of these approaches let really small numbers of people build really big distributed systems for very low cost. And that means everyone's having to take a new approach to how these systems work when they're in the field. I'm going to talk a bit more about the reconciliation and convergence loop here. So what I'm really describing here is DevOps has a lot of really good principles that have been proven to be effective, and we've covered some of those. But there is a even more opinionated way to think about DevOps. So I would say GitOps is really kind of a subset of, it's an opinionated subset of DevOps. So here's what we mean by GitOps. So everything in source control. This lets you be repeatable. Like you should be able to take your oops, there we go. You should be able to take your thing and build it from only artifacts in source control. Anyone practicing DevOps would agree this is the way you should be working. Okay, now, so that's good. Declarative configuration. So if you've been around the Kubernetes world for a while, you will see that this is very much the way, from a philosophical perspective, Kubernetes works. There are good reasons why a declarative configuration helps, and I'll talk about that here in a moment. Automation. Robots have to do all the work. Robots have to do the work based on the declarative configuration. One of the reasons those two things go together is that declarative configuration makes it easy for the humans to reason about what the robots are going to go and do. And so far, at least, they are not yet our overlords. And then this, I think, is the most opinionated part of the GitOps view of how to attack operations at scale. Continuous convergence and healing. So you have a declarative state, robots are doing the work. The robots are also continuously converging the current state back to the desired state. And you're going to hear more about this in detail from some of from the next two speakers as well. All right, so here we go in more detail. This one's probably the most obvious. I think I'll spend the least time on it. One of the key things here is that we're taking practices that have been well understood in the dev world and applying it to the ops world. Code reviews. How do you do code reviews for operations? Well, you should do it the same way. You have policies. Do you have more than one set of eyes on every change before that pull request is merged? You probably should. However, maybe your risk tolerance is high for certain things. So you have a policy here. You can use the same set of tooling. Again, reducing the sprawl by using common tooling and approaches. A declarative approach. It's easier to reason about this at scale. It really is a discipline simplification. One of the things that this also lets you do is it doesn't let just humans reason about what's in these declarative statements. It also lets you build additional automation around it, which means you can do things like policy. You can much more easily do policy enforcement, check for best practices. So again, define the intent, let the robots do the work. Defines the convergence point that you want your system to approach. So here is, I would say, the hardest thing to do. And this is the productivity, this is the velocity chasm that if your org really wants to go faster, you probably have to tackle, which is most organizations are terrified of doing this. They really feel that if they get the humans in the loop, things will be better. It turns out that's not the case. It feels better, it doesn't actually work better. So this is the big deal. If at AWS, if we have humans involved in deployments, we're terrified, constantly working to make sure that that isn't the case. So if you can cross this point here, you're on your way to a velocity flywheel. Okay, so continuous convergence, drift management. Philosophically, what are we talking about here? define the state of the system, measure the state of the system, compare it to the desired state, take some action. Now, the robots are not yet our overlords, so that means they don't always know what to do. The act might be, hey, this is too complicated. I need some humans to help. Alert. Or it might be, this node just died. I better restart the node because I'm supposed to have this many nodes and I'm supposed to have this many pods. And in that case, the Kubernetes robot will do lots of work on your behalf in order to return to desired state. More on this in the coming talks. All right, so lots of hard stuff there. There's also some even harder stuff. And it turns out even more effective stuff to work on. So the next wave after continuous or automated deployment is progressive deployment. All right, well, so what is progressive deployment? Why should you care? Blast radius. So if you put all the robots to work, you have a big system, it needs to run all the time, and you say upgrade from A to B, and it just goes and does it. What if your tests weren't good enough? What if there was something you didn't think about? Like, these are chaotic distributed systems. You may not have thought of everything. So you really don't want to blow up everything by allowing your automated deployment to do everything all at once. So these are the kinds of things you want to do. It all has to be automated, but it doesn't all have to be at once. So for example, you might say, well, let me roll out a little bit of this thing first. In fact, probably should roll out a little bit of this thing first. Are all the tests passing? Are we getting tickets open? Is everything good? Do the robots say that everything is healthy? Okay, let me roll out a little bit more of it. Well, things are still looking good. At this point, robots, just roll out everything at high speed. We've figured out what is our acceptable risk mitigation for this rollout. Make sure you get it done in the next 24 hours. This is the kind of declarative intent that we're talking about. Or perhaps you might want to roll out slowly, but fully into one part of the world, and then everywhere else once you know that part of the world is working well. Or you might say, we have certain users that are more tolerant of problems than others. Let's roll out to them first. So blast radius management is really all about how do you go fast with automation, but still be safe, still provide your users a high quality experience, and how do we let the automation manage that? So blast radius management is really the way to think about it. In order to do that, you need very fine control over deployment strategies. Not every microservice might roll out with the same strategy. You might have some that are inherently use less or have a higher risk tolerance, and you might have fundamental services that need to be rolled out very carefully. You have to be able to control your rollout scope really carefully, and you need to be able to see who sees it, how much of it gets where. So yes, all of this is complicated, but the robots are here to help. Kubernetes. Kubernetes is a pretty sophisticated robot at this point. It has all kinds of things built into it natively that make automated deployment, progressive deployment, all the basic tools that you need in order to make this work are there. Declarative approach, the idea of controllers that are constantly doing convergence is the way Kubernetes is built. It's designed to support an immutable approach. As a container-based system, it has things like deployments built into them that actually will help you roll things out and roll things back. Now, what it doesn't have is it doesn't have all the sophisticated strategies that you might want. Do this on day one, do this on day two, wait 5 days, then roll out the rest. All of the basic building blocks are there, but you still need some additional systems on top to provide the kind of sophistication that I've been talking about. You need to be able to do fancy things with ingress to be able to route traffic from one to another. It has all of these organic healing properties. The robots fix lots of things in those convergence loops for you. So here's the next layer of robots coming to live on Kubernetes. We're really happy. Hope some of you saw the blog post from last week, but we're using this event to talk about Argo CD and Flex CD joining forces. Best of both. We're doing this as an open source collaboration along with Weaveworks and Intuit and some other folks. Please come join us on making this better. So with that introduction, Pratik, where are you? Pratik is going to come and talk to us about how they've been using GitOps at Intuit. Thank you very much.